need to search documentation from directly inside your Python code. You'll see how FastMCP's client lets you query its own documentation server with a single async call. We'll connect to the live FastMCP docs, execute a search tool, and print the results, all in under 10 lines of code. Import Asyncio. From FastMCP import client. Async def main. Async with client. https://gofastmcp as client. Result equals await client call tool. Name equals search FastMCP. Arguments query deploy a FastMCP server. Print result. Asyncio run main. This demonstrates the client-server pattern for AI tool integration using the Model Context Protocol. The code shows how a Python client can remotely invoke tools exposed by an MCP server, abstracting the network communication behind a simple async interface. What makes this distinctive is the seamless bridge between local Python code and distributed AI capabilities, with the protocol handling serialization, transport, and discovery automatically. The pattern works by establishing a clean separation between tool consumers and providers. Clients interact with tools through a standardized interface that hides implementation details, while servers expose functionality through declarative tool definitions. This design enables loose coupling, where clients only need to know the tool name and input schema, not the server's location, technology stack, or internal workflow. This approach solves the integration complexity of connecting AI models to backend systems. It eliminates the need for custom API clients, manual request handling, or protocol-specific code, while maintaining type safety through Python's native type hints. The pattern is particularly valuable when building LLM applications that need to interact with multiple tools across different services, or when you want to expose existing Python functions to AI systems without rewriting them as HTTP APIs. Let's break it down line by line. Import Asyncio. Imports Python's built-in Asyncio library, enabling asynchronous I/O operations. This is required for the async await syntax used throughout the script and for running the async main function. Without it, the FastMCP client's non-blocking network calls wouldn't work. From FastMCP import client. This imports the client class from FastMCP, the primary interface for connecting to MCP servers. It handles authentication, connection pooling, and request serialization under the hood. Async def main. Defines an async entry point. This is the standard pattern for async scripts, allowing await usage inside. The function name main is conventional for the primary execution coroutine. Async with client. https://gofastmcp as client. This uses an async context manager to handle the FastMCP client connection. The pattern guarantees proper resource cleanup when the block exits, preventing connection leaks. All MCP client interactions should use this pattern for reliable connection lifecycle management. Result equals await client call tool. This invokes the search FastMCP tool asynchronously, passing the query arguments. The await ensures the call completes before proceeding, handling the async operation properly within the context manager's scope. Name equals search FastMCP. This specifies which FastMCP tool to execute. The name must exactly match a registered tool on the server, ensuring the correct function gets called with the provided arguments. Arguments query deploy a FastMCP server. This passes the query string as tool arguments in dictionary format. FastMCP tools expect structured input this way, with the dictionary keys matching the tool's parameter names. The pattern ensures type safety and explicit parameter passing between client and server. This closing parenthesis terminates the call tool method invocation, finalizing the AI tool execution request with all required arguments. It ensures the query and tool name are properly packaged before the await suspends execution until the server responds. Standard Python syntax for method calls, nothing special here. Print result outputs the tool's response to standard out. This is the simplest way to verify the async call succeeded and inspect the return data structure. In production, you'd typically process or return this result instead of printing.
Asyncio, run main.
This boots the async event loop and executes main, the entry point for our async operations. Without Asyncio, run, the coroutine would never execute, as Python doesn't automatically start async contexts. It's the standard pattern for running top-level async code in scripts. FastMCP async client pattern. This async context manager and awaitable call structure is the standard way to interact with FastMCP servers, enabling non-blocking AI tool invocations with automatic connection management. Watch out! The client must be instantiated with the full MCP endpoint URL, not just the domain, or you'll get silent connection failures. Key takeaway: this pattern handles both the connection lifecycle and RPC execution in just 4 lines of code. Part 2 of 2 in our FastMCP 2 series.
The await that appears to pause is actually the moment the system moves fastest.